Assalamualaikum and good day. We from Group 10 we present our Project 1. Before that, our group consists of 6 persons. IDHAM MUKHRIZ, Muhammad HIRFAN, Wan Nur Alia SYAFIQAH, Muhammad ALIF SYAZWAN, Abang Zul Akmal, Muhammad ZIKRI bin AMAN, and that's all. Our project title is Classification of Sentinel 2 Satellite Image for the State of Kelantan. For introduction, land use and land cover mapping is one of the most important applications of remote sensing for monitoring environment changes, supporting land management, assisting sustainable development planning. For our project, we cover Kelantan area. Kelantan is characterized by diverse land cover types, and it also influenced by seasonal monsoon condition and extensive river system, making the land cover monitoring particularly important for environmental management and disaster mitigation. For this project, remote sensing techniques are applied to classify and map the land use and land cover of Kelantan using Sentinel-2 satellite image. We have 4 objectives. The first one is to produce a land use and land cover classification map of Kelantan using remote sensing imagery. The second one is to identify and classify major land cover categories based on established land use and land cover classification rules. The third one is to analyze the spatial distribution of land cover classes within the study area. And the last one is to assess the accuracy and reliability of the classification results. For our study area is the project is in state of Kelantan Darul Naim. The states cover a large geographical area consisting of various land cover types. Dense tropical forests dominate the southern and central regions, while agricultural activities are widely distributed throughout the state. Kelantan contains numerous rivers, which plays a significant role in the state's hydrographical system. Urban and built-up areas are mainly concentrated around Kota Baru and other district centers. This made Kelantan an ideal study area for evaluating the effectiveness of remote sensing technique in land use and land cover classification.
Moving on to the methodology, our project implement 2 distinct approach for land use and land cover mapping, a pixel-based classification and object-based classification. For both methods, the input data used was Sentinel-2 Level 2A surface reflectance imagery. The first step for both workflows involved clipping this raster imagery using the officially shapefile boundary of the state of Kelantan to isolate our study area. For the pixel-based approach, we incorporate both unsupervised classification to understand initial spectral clusters, followed by supervised classification using algorithms like random forest or support vector machines. For the object-based approach, the clip imagery underwent multi-resolution segmentation to form image objects, followed by zonal statistics, extraction, and vector classification. Both parts conclude with area statistics generation and rigorous accuracy assessments. Let's dive a bit deeper into the execution steps. In the pixel-based workflow, supervised classification was conducted using carefully labeled training samples that accurately represent our selected land use and land cover class. This allows us to generate a classification report and execute an accuracy assessment using a confusion matrix to evaluate the reliability of our final pixel-based classification map. Simultaneously, for the object-based workflow, the process begins by segmenting the clip Sentinel-2 image. Instead of analyzing individual pixels, we calculate zonal statistics to extract valuable spectral information from each segment object as a whole. Once the object attributes were extracted, we combine them with our reference vector dataset using a join by location operation. This critical step transfers the ground truth land cover information directly onto our segment object. From there, we apply a train vector classifier algorithm to build a robust classification model, which was then used to classify and visualize our final object-based map. Just like the pixel-based approach, the classification report and confusion matrix were generated. This structure setup allows us to directly compare both maps in terms of overall performance, classification accuracy, and visual effectiveness. Now let us move on to the most crucial part of the project, the result and analysis. In the next few slides, we will look at the quantitative data yield by our pixel-based classification plugin and look at how the land area is distributed across the different classes. As you can see on the screen, these are the direct outputs generated using the semi-automatic classification plugin in QGIS. We have summarized the pixel sums, percentage distributions, and total area in square meters for each of our 4 raster values. Raster values 1 covers a substantial portion of the area, consisting of over 122 million pixels, which equates to 44.14% of the total classified area. Raster value 2 represents a very minor footprint, taking up only 0.10%. Raster value 3 accounts for 0.70% of the area. Raster value 4 is the dominant land cover class in this classification, consisting of over 152 million pixels and making up 55.06% of the study area.
So on this slide, we can see the confusion metric for the pixel-based classification. So the confusion metric is used to compare the classified data with the reference data in order to evaluate the accuracy of the classification result. So based on the result obtained, most of the land cover class were correctly classified, indicating that the pixel-based approach performed very well in the study. According to the accuracy assessment, the pixel-based classification achieved an overall accuracy of 100% with a kappa coefficient of 1.000. This indicate a perfect agreement between the classified image and the reference data used in the assessment. Although the numerical accuracy is very high, this approach still has some limitation in terms of visual quality. So this slide presents the classification report for the object-based classification approach. Unlike the pixel-based method, object-based classification group neighboring pixel into meaningful image object based on their spectral, spatial, and textural characteristic. As a result, this approach provides a more realistic representation of land cover features. For the object-based classification, the overall accuracy achieved was 99.74% with a kappa coefficient of approximately 0.997. Although this value is slightly lower than the pixel-based classification, the accuracy is still considered very high. Therefore, the object-based approach is also capable of producing reliable and accurate classification results. Okay, so this slide shows the comparison between the pixel-based and object-based classification approach. The pixel-based method achieves a slightly higher numerical accuracy. However, the resulting map contains isolated pixels, commonly known as the salt and pepper effect. On the other hand, the object-based classification produces smoother polygon and more realistic land cover boundaries. Therefore, the pixel-based approach performs better in terms of numerical accuracy, while the object-based approach provides better visual quality and a more meaningful representation of land cover features. Okay, so this slide shows the final pixel-based classification map of Kelantan. Since the classification is performed on individual pixels, Some isolated pixel and fragment region can be observed throughout the map. This phenomenon is commonly known as the salt and pepper effect. Although the map achieves very high numerical accuracy, the visual appearance is slightly less smooth due to the presence of these scattered pixels. Okay, so this slide presents the final object-based classification map. Compared to the pixel-based map, the land cover boundary appears smoother and more continuous because neighboring pixels are grouped into meaningful object before classification. As a result, the map provides a more realistic representation of the actual land cover distribution and improve the overall visual quality of the classification result.
Okay, so this is for the discussion based on the result. Okay, the finding demonstrate that both pixel-based classification and object-based classification are effective method for generating land use and land cover maps using Sentinel-2 Level 2A imagery. So for the pixel-based classification, produce the highest numerical accuracy, achieve an overall accuracy of 100% and a kappa coefficient of 1.000. So the result map contain isolate pixel and small fragment region that reduce its visual consistency. Although the numerical accuracy was marginally lower, the result map displays smoother polygon and more realistic land cover boundaries because the classification was based on image object rather than individual pixel. So for the limitation, processing the entire state of Kelantan require a substantial amount of memory and processing time. Only a portion of the study area was used during several stages of the object-based processing. Next limitation, when we process using the object-based approach, the result polygon become extremely dense. So for overall, both approach have their own advantage. Pixel-based classification provide a simpler and faster workflow with excellent numerical accuracy, while object-based classification offers superior visual quality and more meaningful representation of land cover feature despite requiring a greater computational resource and longer processing time.
So in conclusion, this project successfully achieved the objectives of producing and evaluating land use and land cover classification maps of Kelantan using Sentinel-2 Level 2A satellite imagery. Using two classification approaches, which is pixel-based classification and object-based classification. The pixel-based classification produced an overall accuracy of 100% with a kappa coefficient of 1, indicating perfect agreement between the classified image and the reference data used in this study. Meanwhile, the object-based classification achieved an overall accuracy of 99.74% and a kappa coefficient of approximately 0.997, demonstrating that it also provided highly reliable classification results. For the visual interpretation, the object-based classification generated a smoother and more realistic land cover map by grouping neighboring pixels into meaningful image objects. In contrast, the pixel-based classification classified each pixel individually, resulting in a greater salt and pepper effect. Therefore, while the pixel-based approach offered a simple workflow and slightly higher classification accuracy, the object-based approach provided better visual representation of land cover boundaries. The several limitations during the implementation of the object-based classification. Due to the limited processing capability of the available computer hardware, the entire state of Kelantan could not be processed efficiently during the segmentation and classification stages. Consequently, only a portion of the study area was used for the object-based workflow to ensure that all processing steps could be completed successfully. Furthermore, when the whole state was processed, the segmented polygons became extremely dense, causing the final map to appear dark and making individual object boundaries difficult to distinguish when viewed at a smaller scale. So overall, for this conclusion, both classification approaches proved to be effective for LULC mapping using Sentinel-2 imagery. The findings indicate that the selection of an appropriate classification method depends on the project objectives, required map quality, available computational resources and processing time. For future work, the use of higher performance computing resources and higher resolution satellite imagery is recommended to improve the efficiency of object-based classification and produce more detailed and accurate land cover maps over larger study areas.
Okay, so I will present on the software QGIS what we do to method, which is pixel-based classification and object-based classification. So for the first method, pixel-based classification, we do combine 4 picture from the Sentinel, from the image from satellite Sentinel 2, which is LA, and we know LA is a image, and image have a atmospheric duration, and this is a result when we combine the all 4 image. And after this we go to the make a boundary on Kelantan, and we merge clip, and which is this to get a boundary. So next, after make this part, and we go to unsupervised classification. So this is a image unsupervised classification. And next, we do a supervised on the unsupervised image, and we can see this is a different from the unsupervised. Okay, so next, when we do this, we can get a classification report from the QGIS. So after this project, and we make a map from the layout manager and get this map. So, and we can export the to PDF. So that's all from pixel based classification. So next, I will present about the method 2, which is object based classification. So this is I will present start from early. For the first part is a clip raster, which is we crop the image, but we do a small area only, because we can see the polygon in detail. So next is a segmentation. So this is a result or segmentation, and we can see the polygon at the map. This. So next, zonal statistic. So this is a zonal statistic we can see, and we can get a attribute table. We can see the count, mean, standard deviation, and mean for each band. So next, join by location, which is point at this location where I before this pick a point at the four different part, which is water bodies, building, vegetation, barren land, and roads. So we can see result of the join. After that, we do a part of class train vector classifier, which is we can know how each point can divide a 5 category, which is water bodies, building, vegetation, barren land, and road. So for the final result, we can see this is a final result. We can see polygon, a part of water bodies, buoy, vegetation, berry land, and road. So we can see. And for the final result, we met map object-based classification. So this is a map. And that's all from us. Thank you.